Hey everyone, welcome to Zero Labs. Today is Wednesday, October 5th, 2016. I'm Mark Brash, your host, and today I have to start an overdue project, and that is the reconstruction of the pellet fire basket for the rocket stove that I have for the workshop. There's been a lot of questions about this still. I get a lot of email asking about the specifics. So in this little video series, I want to go through exactly how I go about determining the proper dimensions for the size opening of practically any rocket stove that you might build. Let's get to it. So I'm going to try to run through this video very quickly. I'm going to be showing you a number of still photos, and in the middle of my presentation, if there's any still photos that you want to look at, I encourage you to stop the video and look at them and study them in detail. But like I said, I am going to try to run through this fairly quickly. This is the pellet fire basket that I've been using for a little over 2 seasons. All right, and it's time. So let's get right into the photos, and then we'll talk about why I need to make another one and how I'm going to go about doing it. So the first photo that I want to show you is an overview of the pellet fire basket. This is the view as seen from the inside of the stove. And what we're looking at is the face of the fire basket closest to the tank. The thing that I want you to note about this photograph are the little winglets at the top edge. With those little winglets, I'm able to bend those tabs up or down to adjust the finished height of the fire basket inside the opening from the floor of the fire of the rocket stove inlet. This is a side view of the same fire basket. You'll notice that the bottom of the fire basket is not symmetrical. It comes to somewhat of a blunt point. This was actually made from a fire basket that I made where the bottom was fully rounded, and the only thing that was different about the wires in the frame was that they were staggered. And to get this shape, I ended up pounding it with a hammer and trying to bend it into shape. So that's why it's quite a bit of an irregular shape. In this close-up, you get an idea of how those loops of wire are staggered beside each other. One hangs down lower than the other. They're staggered at about 1/4 of an inch. Here's an angled view of the bottom of the fire basket, and you can see quite a bit of degradation in those middle steel rods there at the bottom that sit inside the burning embers. You'll get another look at that in just a second. The rough dimensions of my fire basket are 1.75 inches on the outside, about 1.25 inches on the inside. I'm sorry, about 1.5 inches on the inside, front to back. And just above where I took this measurement, I'm measuring the front to back distance of the rods that form the braces that are welded to the front and back of the fire basket near the top of the inlet. Here's another close-up of the loops at the bottom, and this is a very good close-up of the bottom of the fire basket, showing how the loops are staggered and all of the erosion that has taken place from the intense heat of the rocket stove. Now, this is, I want to point out, over the course of 2 years. I don't burn my rocket stove continually. If you were to run this fire basket in a rocket stove to heat your home, you would probably end up having to replace one of these every year. Here is a series of photographs showing the placement of the fire basket inside the opening of the rocket stove, the fuel opening of the rocket stove. This is an overhead view showing it moved all the way to the front. We'll talk about that in just a second. Here's a slightly lower angle view so that you can see how it sits in the opening. Here's looking at it pretty much straight on, and you can see roughly how high above the opening the rest of the fire basket extends. All of this, of course, is contained inside the air plenum that sits on top of the whole assembly, and it's sealed up where the air inlet comes in on the right hand side. Here's a angled elevation or an angled view to give you another detail. Here's a view of the burn chamber with the front brick removed so that you can see the full length of the fire basket sitting inside the burn chamber of the rocket stove. Here's a close-up of the bottom of the burn chamber. You'll see some extinguished pellets there that don't look like they're fully consumed. That's because these are the pellets that were left over at the end of a burn cycle that I shook out of the fire basket before removing it from the burn chamber. Here's another close-up showing the pile of pellets that were shaken loose from the basket after the end of the burn cycle. What I want you to note here is that in the course of normal operation, as this pile does begin to build up slightly, the gap decreases. As the gap decreases, the air velocity passing through it increases, and it tends to keep itself clear because as the air velocity increases, it tends to carry the ash further down the horizontal burn chamber of the rocket stove and along the floor, as illustrated by this photo right here. So towards the front, you see the pile that I've shaken loose, and in the middle of this little alleyway, you can still see bare brick. And this is the total extent of the amount of ash that was created from 4 pounds of pellets during this burn cycle. In this photo, I'm trying to demonstrate what the height is above the floor of the burn chamber. This is a piece of 3/4 inch pine. It will not pass underneath the fire basket. The actual height is just a little bit less than 5/8 of an inch from the loops that hang the lowest, and the loops that are higher probably are about 3/4 of an inch off the floor. There's another angled view to get an idea. All right, and the reason that the gap there is so tight, it does tend to be a little bit restrictive, but it also forces quite a bit more air to pass through the pellets that are burning at the bottom of the fire basket. Now, when the basket is placed towards the front or closest to the drum, all right, almost all of the air entering through the burn chamber has to pass behind the basket, underneath, and through the pellets. In this position, it tends to choke out the airflow a little bit. And the way you adjust the air mixture is by simply adjusting where the pellet basket rests inside the burn chamber. By sliding it back just a little bit, you allow air to pass in front of the pellets rather than passing through the pellets, and doing so leans the mixture out and allows you to control the air to fuel ratio that gives you the most efficient burn from your rocket stove. The other thing that I'd like you to note in this photo is that the fire basket itself, if you notice, occupies almost 2/3 of the entire opening. In fact, it's roughly 60-40. The opening of my burn chamber is 3.5 inches wide by 3.25 inches front to back. Yours may or may not be the same. And when you vary, of course, the size of the opening, you need to adapt the size of your fire basket to match. The point I want to make about this photo, however, is that even though my fire basket takes up 60% of the opening and only 40% remains to allow air to pass through or behind the fire basket, that actually is not detrimental, it's beneficial. Because by restricting the size of the opening, you end up increasing the velocity of the airflow, and that's extremely important in the burn of the material, of your fuel. The same thing actually occurs when you take and stuff twigs and sticks and pieces of wood into the opening of your burn chamber. All right? By the very act of placing wood in that opening is restricting the cross-sectional surface area, increasing the air velocity. That's why you will find if you just burn sticks in there that there's an optimum fill ratio, that you'll get the most efficient burn. It's exactly the same principle, only with the pellet fire basket, you have much more precise control of the burn so that you get a consistent burn all of the time. Now, to build the new fire basket, I'm going to be using these steel welding rods that I purchased on eBay. These are 1/8 inch thick, 36-inch long stainless steel, 304 stainless steel. They weren't very expensive, and 1/8 inch is probably the smallest you could go. If I was to do this again, I will make these 3/16 of an inch in diameter so that I get more service life out of the fire basket. But right now, I've still got enough to make probably, wow, I want to say 3 more fire baskets. And I bought the lot. It was about 10 pounds. I want to say it was about $40 for 10 pounds. And you get a whole bunch of rods in this package. The rods themselves, like I said, are 36 inches long, and if I take my tape measure and measure around the circumference, around the top lip, through the bottom, and up to the top lip on the front side, it's 17 inches. So I can cut each of these rods in half and get 2 ribs in my fire basket out of 1 rod. That's what's going to allow me to make 3 more baskets out of what I've got here in materials. To bend those up, I'm going to take this block of wood, I'm going to put some pegs in it in the appropriate locations, and I'm going to create a jig to bend the welding rods into the shape that I want them before I weld them up. And then I take some 3/16 inch thick pieces of steel to set the gap between the rods, and then weld the braces on the front and back, top and bottom of the fire basket. So as I said earlier, I want to document this process fully so that I can explain to you exactly how to size one appropriately for any rocket stove that you might happen to build. I'm also going to be building a second one of these with some stainless steel rods that are being sent to me by one of my nerd herd in my chat room. So I have a chat room open right now. I have a live audience watching me record this video, and one of those regular members has a rocket stove very similar to mine, and has asked me to build him a pellet basket. He's sending me the rods. I'll bend them up and weld them for him, and send him back a finished piece that hopefully is going to work properly. We'll see if my theories work in practice when he gets his and fires it up. Anyway, that's all for now. I need to take this and use it maybe 1 or 2 last times to warm up the shop as I make the new one to replace it, and then we'll have a retirement ceremony for this. Thank you all for watching. As always, please rate, share, comment, and subscribe to my videos. And peace, everybody.